I guess we're running. So I have to do the link thing. you know, sorry, you can't do this ahead of time. So you do have to get it, and then you have to post it into the other window, and blah 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 blah. Blah. So, sorry, can't really pay attention to you. I should be able to multitask with more efficiency, but old dog, new tricks, all that kind of shit. So you get what you get. So the link is in the low bar if you need it or want it. It should be there now. Probably. Yeah, maybe. Anyway, so physics room thing. See if anybody shows up. Yeah, it's going to be off hours for the Brits, and then it's numbly numb. It's too early for him, and so whatever. We're see who shows up, what shows up. Should be a good time for a Mr. Natural, for example, but we'll have to see. Maybe we'll have to find out what he's up to when, and see if we can schedule him a point at some point to his convenience, make a room for his convenience. So if you'd like a room to your convenience, I don't know when the comments are going to work. I mean, I don't know why they break the comments while the video's running, but they do. I don't know what this thing is. I don't know if I want to click anything. You never know what you're going to get. Oh, okay, that's the chat thing. But if you want to leave a comment somewhere, well, you could PM, I guess, right? I might read it in the next month or so. But anyway, if there's somebody who wants to have a conversation, but they can't, this schedule doesn't work for them, we could arrange something where I could have a room at some other time. So I'm just going to alternate between midnight and something like 5 a.m. or something like that. So every 2 days, something like that. Something like that. Saying that to, well, yeah, I'm saying that to whoever's listening after the video gets posted. Yeah, there's nobody there now. So anyway, yeah, so that's pretty much all I wanted to say about that. So I'll just do a physics video, I suppose, and see if anybody shows up, and if not, fine. About stuff that I'm, so the Alan aspect thing came up in Piro's idiotic room. The subject of entanglement, this idea of the photons must be umbilically connected to each other somehow, because they came out of the same atom. They're somehow spiritually connected. So I guess the first thing to say is somehow there's photons when they're created. They have some kind of blood brother. Maybe I'll write that down. Some sort of partner that forever, as long as the photon exists, which I technically would argue would be forever, in some form or another, inside of a piece of matter or not, that they're entangled. So we'll write down the word entangled. So this is another one of those things, right? They have a choice. They can assume that an experiment means Bugs Bunny stole Daffy Duck's key to the restroom and then dressed as a woman and then went to the ladies' room. I mean, they can assume some sort of bizarre scenario, or they can say, oh, there has to be a better answer. And it seems quite obvious that, I think obvious, that physics just doesn't care to do this. Let's keep it rational, stupid. Well, that's kind of a good name. Let's keep it rational, stupid. Yeah. There's just no desire to do that. No desire to keep it with any kind of boundaries of physics, like coming up with physical explanations. They just want to do this magical photon-y thing. And it just, like I said, there's there's just no other conclusion to draw, because they just talk like this Allen aspect experiment proves, prove, proof, 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 it proves, proof, proof, proof. And, you know, it, in my opinion, it proves that they will jump to a conclusion if you give them an opportunity. Give them an opportunity to jump to some sort of bizarre conclusion, and they will bite every single time. So if you could make a wacky experiment that proposes to prove that Santa Claus exists, they'll go for it. You just have to make it a complex enough experiment that no one's going to bother taking it apart and trying to do it over and do it right. You know, it's just too irritating. Well, so and the key to this experiment apparently is the invention of some wacky switching device, you know, that changes the path of a photon, allows it to go one way or another. And somehow we're certain that that doesn't affect its polarization. So I saw a documentary where they actually had Allen Aspect talking. You know, he speaks bad English, but it's comprehensible. And apparently he's under the impression that photons can change their polarization. So a photon doesn't need, you know, I hate to even say it because it just sounds so, how could you believe that? That a photon could change its polarization by its volition. Like it somehow has something to say about its polarization. Like it does it without something else changing it. And what they're saying is changing it is this spooky action, this entanglement communication. And the photon says, oh, okay, I'm supposed to change my polarization? No problem. And you're just saying, you know, I mean, you know, I could, if you could, you know, you have a rainbow and that's polarized light. Let's say it shined through the whole universe and went across the whole universe. It'd still be polarized when it got to the other side of the universe. There's nothing that's going to change its polarization unless the light interacts with an electron and has its polarization changed. It has to interact with something that's going to consume it and regurgitate it in a new polarized position. But you can't change the polarization of a photon. The polarization is a feature of it that is not mutable. It's a fundament of the, like it's light speed. It's something you can't change. It's a property it has. And that photon has that property and it can never change it. You can only absorb the photon of one polarization and re-emit a photon of a different polarization. But no photon keeps its polarization. So that's, I mean, no, will surrender it. So let's write that down as that polarization is an absolute property. Is that the right to say? A fundamental property. And then all you can do is you can change photons, but you can't change polarization. So maybe I'll write that down. Change photons. Not polarization. So if you're to reconfigure the, so this is the assumption built into this experiment. So like the two-slit experiment where the assumption is light's a wave, that's what they're thinking before experiment through the processing of the experiment. And I just thought that was kind of a glaring statement, you know, that obviously Aspect thinks polarization is something a photon can change, that you don't have to change the photon to change polarization. So that's the first piece of the first disputed premise of the variables in the experiment and how conclusions might change based on that understanding. But the communication, if you have spooky action at a distance, the spooky action is that your filters are changing, not your photons. That the filters are communicating with each other, that the detectors are communicating with each other, not the photons. Because it seems to me that the filter or the detector is the thing that's changing the photon, not the photons. This polarization can't be changed. Again, polarization of the individual photons can't be changed. You have to exchange the photons for photons of a different polarization. You have to readmit them. And all interactions are whatever the right word would be, recreations of what goes in. You know, something goes in, it's processed, and then something goes out. And in most cases, they'll throw out the same kind of stuff that came in. But the point is it's not exactly the same stuff. It is a different photon. Just it can have the same polarization or a different polarization, depending on the movement of the processing filter, the state of the electrons. All right, so another assumption in the experiment is the creation of the photons at some kind of regular interval. You know, the assumption is that I shine a certain frequency of light at some calcium, and photons are regularly produced in some kind of consistent manner. And I don't think they have evidence of that either, that there could be lots of variables depending on the function of the calcium in terms of its metabolism. So it could be adding a fluctuation in terms of what polarization it is. 90%, the light is produced is 90% polarized at the peak point, and it's only 80% polarized at the low point, based on the function of the calcium in terms of being a catalyst for this experiment. So I'll write down catalyst. So it's a good word, because that's what they're using the calcium as. I'll probably never be able to understand what I just wrote here. So it's another assumption, is that they have a stream of light that is of a consistent manner, and that all inconsistencies are a product of something that happens down the road in the experiment rather than something that happens at the source of the experiment. So again, you know, so that's another one of the assumptions. So this whole experiment depends on an error rate, you know, and so it's really very inexact in that they're taking averages over time of hundreds of events, and you know, and coming up with some kind of number, like there's a probability number or a percentage number that you would expect that would be 12%, and instead it's 15%. And so it's not a huge, it's not like a glaringly obvious kind of result. It's this kind of result where it exceeds some sort of percentage expectation. So it's not like you get some kind of black and white answer. You get an answer that's dependent on an intensity that doesn't exist. And so anything in your experiment could be creating that change in intensity. So I guess I'm just trying to say is there's a huge difference between you know, a 10-degree difference in temperature. Yes, it's significant, but you can understand that lots of things could cause that 10-degree difference in temperature. It's not like it's the difference between boiling water and ice. That's not the kind of results they got. The difference is it's 170 degrees and it should be 180 degrees. All right. So the other thing that comes into this is these stupid, whatever it's called, Bell's inequalities. So I don't remember exactly. I remember when I looked into it, it was so convoluted, I didn't know exactly what the fuck it was saying. But I'm obviously going to have to revisit that if I'm going to make some arguments about this particular experiment. Because apparently this is some kind of clincher to this whole thing, because Bell's inequalities, if we accept them, you're not allowed to violate them. And because this number isn't the number they expect, it violates Bell's inequalities, and therefore it can't be right. So, I don't think Einstein was too pleased with Bell's inequalities. I'm not quite sure, but I'm wondering whether that was on his bullshit list or not. Because it just seems like a complex statement that somehow we're not allowed to violate whatever this is in terms of a percentage of error that's possible in these kinds of experiments. And somehow quantum theory is all connected to this Bell inequality crap. And so I have to obviously get more knowledge on that subject. So the experiment just has to do with polarization. So they shoot photons, and it seems they only want to do the experiment on photons that don't match, which is also very strange. So they regularly come out with the same polarization, but apparently in some circumstances they come out with not the same polarization. And that should be a giveaway right away that something must have gone wrong. But anyway, it seems like they're only paying attention to the ones that have dissimilar polarization, and that somehow they end up having the same polarization later through this magical communication with each other. So yeah, I'm not too clear on that part of the experiment, why exactly this switching what path the photon takes has something to do with anything. So the real point would be is that there's, in each photon they send in a different direction. Presumably that's how they come out, going in a different direction. These Siamese twin photons that are capable of feeling each other's pain. They go through a polarizer, and they're called polarizers because they polarize light. So again, this is why are we talking about light having the ability to change its polarization? Its polarization is changed by polarizers. And how do polarizers change the polarization? They probably absorb the photon and readmit it with a different polarization. It's the two-slit experiment. The surface consumes the photon and readmits it in a diffracted angle. So anyway, so it's both a detector, the polarizer, in a sense. I mean, clearly, if there's any functions involved, it's collapsing them because it is going to interfere with the photon if it's going to polarize it. And even if it doesn't polarize it, it may well interfere with it. It goes in one polarization, comes out the same polarization. That's clearly a possibility. It's just that if it comes in the wrong polarization, it'll have its polarization changed. So polarizers fundamentally, they'll block something that's completely not the right polarization. So if it's this and down, it'll block it. And if it's this and up, it'll pass it. So it's not, it's not like it only passes this and only blocks this. There's a whole range that it permits to, and when it admits it, it now changes it. So if it was this, it's now this. So that's a key point here, is this: the polarizer isn't just detecting polarization, it's creating polarization. And it seems, I'm just saying it seems, from what Alan Aspect was saying, that he's thinking more of these filters as just measuring what polarization something has, like detecting it and giving you a result, rather than actually changing something's polarization. And it seems clear that the photons that go in with this polarization, new photons are ejected with this polarization. So it's not an issue of just measuring, it's creating polarization. And so yes, so that's one polarizer, and then it goes into this mirrored device or it gets switched. So it goes straight or it gets switched. Now, it seems presumably the switching is going to be through a mirror. And so I'm not sure exactly how they do that. I mean, I guess ideally you should use a prism or something. So in that case, both photons would have the same interaction in the sense they both have to go through the crystal. You're still arguing that one is getting deflected, which is a different interaction than passing through. Passing through glass and getting reflected by glass are different interactions. They'll take a different amount of time and will affect the photon in different ways. So it's this idea that you can magically switch the direction of a photon without having substantially interfered with it is another presumption in the experiment that I think is insane. I mean, why would you can't presume that. You would have to presume exactly the opposite. And then you'd have to be able to in some way explain how whatever affects the transition device is causing have absolutely nothing to do with your results. That changing the photon doesn't mean you've changed the experiment. And again, that's what we're talking about. We're talking about this blood brother photon. If you change its polarization, it's not a blood brother anymore. So how could it possibly be communicating? The electron ate the blood brother, consumed it, and readmitted a new photon. Now, how could they possibly be spiritually connected anymore? And the mirror is doing the same thing. If it's factually true that photons are absorbed in the process of reflection, then every time you reflect a photon, it's not the same photon technically. It's a new photon with the same vector, a proportional vector, angle of incidence, angle of refraction. So it is doing the appropriate thing as the photon you sent. It's doing the same behavior, but it's not the same photon. It's another piece of the electron, a different piece of a specific polarization. So the process of reflection causes polarization. The process of passing it through a polarizer polarizes. So it seems you have an awful lot of things causing polarization, and then you're claiming at the end of the experiment that they didn't make any polarization, that the photon made polarization. It decided to change its polarization, and that somehow these filters didn't do it. And of course they did. So this is this is a substantial problem. And I think that this is sort of known in physics, that you can do this eraser thing. I mean, you can erase the polarization that the polarizer causes by just putting another filter in between and bending readmitting the photon in a angular that is passable through the next filter. And but any filter will always consume some portion of your photons, even the ones that were the right polarization, because they hit the bars. I mean, if I throw a frisbee through bars, right, this way, so I'm throwing a frisbee on end through a jail cell, and it's really likely to get through because there's a lot of openings, right? And if it's at a little bit of an angle, what happens, what I would argue is happening in the real world, is that the electrons on the edges are consuming the photon and readmitting it, and probably at a diffracted angle. And it will be readmitted at the proper polarization though. So if the frisbee went in this way, it'll come out this way, but it's not the same frisbee in the real world. For the frisbee example, let's just say the bar is bended. It hits the bars and it's bent straight, and they all come out of the other end straight. So if they come in a little bit crooked, they'll make it through the bars. But the point is, some of the frisbees, even though they're the right polarization, they hit the bar, okay, right head on. And even though they're the right polarization, they were filtered out as if they were the wrong polarization. So you always have to recognize that there's a percentage of your light even when it's the right polarization, that's going to get killed by the filter. And you're not going to have any of the opposite effect, which is none of the ones that are wrong are going to be able to get through at all. There's no way to stop a wrong and turn into it gets through the bars. So no frisbee going this way is ever getting through. And some percentage of the frisbees, though, that are correct aren't getting through. So until I haven't heard them deal with that argument, of course, because that's a detailed argument, and you'd have to go through a lot of minutia to see if that has been addressed. But clearly, logically, you could argue that that imbalance in circumstance certainly could explain a 10% difference later in your results. Because if you're assuming that the filter works reliably, that is, it's consistent in some way, even if it has consistent errors. If you're assuming that whatever extra ones are getting blocked the wrong way are getting through the wrong way, so the same number of wrong throughs or the same numbers of right blocks, if that's part of your calculation, the assumption that those two numbers are the same, then clearly you're not going to have your conclusions are going to be incorrect because your premises going in were incorrect, and that will fuck your results. So I guess I'll write that down. It's a good thing just to keep in mind about these filters, that a polarizing filter will kill good polarization. I'll write that down. Some percentage of it, depending on how tight the bars are, obviously that percentage goes up. So the more strict your polarizing filter, the more bars, the more likely you are to kill a true positive, something that should have made it through the filter, that would have made it through the filter if the filter wasn't too tight. So anyway, so I'm just saying, I think as you go through the experiment, there's lots of places where there are simple assumptions, and I would argue that these are that there's a kind of sloppiness, because if you're going to make a big claim, you really need to have an experiment that accounts for everything in detail. And just the idea, the very fact that he is saying or implying that he believes photons can change their polarization at will, so to speak, or as some mechanism inside the photon. I don't know how he creates that mechanism. I don't know what experiment he thinks demonstrates a photon ever performing this feat of changing its polarization, except one of these convoluted experiments where you pretend the filter isn't doing it. So this would be, I guess, in the category of the hidden variable. These arguments is that there's variables here that are, in my opinion, aren't even being thoroughly explored. And so they dismiss the idea of a hidden variable, and it seems they haven't even tried to find the hidden variable. They're just dismissing it even as an idea, as if their Bell inequality exempts them from the fact that they have a wrong presumption in their equations. All right, that was, see, this is a really, when you start getting into the minutia of this stuff, and this is obviously an experiment that's much more complicated than many more moving parts, so to speak, than the two-slit experiment. And as I've pointed out, I think quite rightly, there's a ton of physicists who, if I ask them 20 questions on the subject of the two-slit experiment, they might get half of them wrong. They have assumptions about what's happening that aren't true. They have assumptions about experiments that have been performed that aren't true. They have false knowledge of the experiment. And that's a really simple experiment. I mean, just simple things. I mean, if I tested them on the depth of the diffraction pattern, the interference pattern in the single slit experiment, and asked them how many bars are in the, are there more or less bars if I make the single slit just as wide as the total of the double slit? Are there more bars with the same wavelength light? You know, questions like that. Like I said, I don't think they're going to get the right answer. I think their assumption is that the single slit experiment creates far less pattern, and it only creates far less pattern when you use you know, a slit that's much smaller than the total volume of the two slit experiment. So if you have the same volume of open space that is light, you'll get a pattern just as deep as in the two slit experiment. And I would argue, I'll make a prediction, if people are willing to test the talking heads of physics, that a large percentage of them will misidentify the truth. They will not accurately answer the question. They will demonstrate that these facts are no interest to them, and yet these facts are critical to what happens in this experiment. And so getting back to that is that you know, we can talk about Huygens, because this aspect thing has a lot of Huygens written all over it. Sounds a lot like some Huygensing going on. Principles that only apply for this one experiment. Assumptions. So Huygens is this contrivance that's used only when you have a single aperture, and yet they call it a principle, as if it happens everywhere when it happens nowhere but in this one circumstance. And if they use it anywhere else, they mathematically eliminate it through a trick. You see, when you count the bars, you could count by starting at 0 and go to 10 or 100, or you can start by going 1, 2, 3, 4, 5, 6, right? So you can count them as things, like they all exist, or you can make something go away by starting by identifying it as a 0. So in math, the 0 is very different than the 1, 2, 3, 4, 5. The 1, 2, 3, 4, 5 are counting things that exist, and a 0 in math is counting something that doesn't exist. So as soon as you identify something as a 0, when it's not a 0, that is, it's the first one, and you've decided to call him 0, you can make him go away. So theoretically, they can make the single slit experiment go away by just identifying, by counting the things, and starting with 0 instead of 1, which would be the appropriate way to count things. If I have actual things, I don't go 0, 1, 2, because when I do that, I have 3 things, and I'm only counting to 2. You see how the cheat works? All I have to do is call him 0. See, he's gone. So I haven't even seen them actually use this particular cheat, but theoretically, you could say Huygens applies and just use a simple trick in the equation where, as long as you identify the bars starting with 0, you will nullify the single slit experiment by just saying you'll not, I mean the slits, you can identify them numerically. And so just count them by just starting with 0. And so then you can make Huygens irrelevant when there's a non-zero. And the only time it's relevant is when there's a 0. So you just blow up the counting process in all the other ones. You just make the number go away, and we can pretend we don't have to pay any attention to it. And you're just going to focus on the 0. So it's just a trick. You know, and I think this is commonly used in much of the mathematics of physics, where they just have little blow-up tricks designed to make something go away, something they don't want to deal with, and they can just make it go away by calling it 0. or infinity or whatever the trigger is. So they can just trigger an explosion that causes the thing to the thing they don't want to disappear. The inconvenient truth goes away. So I've been arguing that obviously they've turned the two-slit experiment into this huge controversy. What slit does it go through? And coming up with interpretations to explain the two-slit experiment. And the real game is the single slit. That's where the interference pattern starts. And obviously it has nothing to do with the number of slits. It has to do with the number of surfaces. So the single slit experiment is really the two-surface experiment. But it's really just a surface experiment, like the aperture that causes interference. It's just the surface that's causing the interference, that's causing the light plus light equals dark. And you can see it with Newton's rings. So when you take a circular aperture, you get what would look like an interference pattern if you projected it linearly. So it looks like an interference pattern. There's no light, light, no light, light, no light. And it's a single surface, technically. And the point is if you could duplicate the circumstance, like if you could take a single surface and duplicate the circumstance of another surface pushing up against it. So that's where it gives itself away. If I just take a single surface and I take a single surface, I don't get detectable diffraction. There's only a tiny percentage of the light is going to go by the surface, and most of the light's going to get out here, and it's just going to wash out anything that could possibly exist. I have no way to get rid of the extra light, so I'm blind to what this surface is doing. I won't be able to see what it's doing. And there's really just no way to fix that without aiming light along the surface. The second issue would be is that even if that were true, even if this surface is creating some diffraction, it may be the real key is that the two surfaces coming together is what really magnifies the surfaces. So as the two surfaces come together, what's happening is the electrons are compressing because they don't like each other, creating field dynamics, pressure dynamics in a sense, and that is causing the extra diffraction. So the whole controversy of what slit did it go through is irrelevant to this mechanics of a single slit. The only thing that's relevant in the mechanics of the single slit is all you have are the surfaces. There's no, what else can it do? There's no other way to create these two waves except to accept that the waves are probably built into the surfaces. That's where your interference is happening, is when the two surfaces have their fields interfere with each other. That's the interference pattern. And the light is merely reflecting what the field is doing proportionally in terms of where it's diffracted. But all of this nonsense, all this whole conversation about what slit it went through, is just negated if you pay attention to the single slit and say that's where you have to explain how it happens. And to explain how it happens by using this Huygens trick of just pretending two waves were created when there's no reason to believe that's true. That principle isn't applied in any other experiment, so why should it be accepted as a principle or something that actually happens, when clearly it doesn't actually happen, because you can't assume it happened in any other experiment without destroying the experiment mathematically. You won't get the right results. So there's no reason to believe Huygens is anything but a trick, a lie, a deception, a way of negating the truth, which is interference is being caused by surfaces, not slits. And you don't have any quandary about what slit it goes through. Clearly, the two surfaces are causing the pattern. All right. What else? Well, the surface says surfaces create diffraction. Two of them cause more diffraction. They multiply the diffraction, increase it, cause more of it. Yeah, there's no. I mean, it's not. It's not a 2 + 2 thing. It's a 2 squared thing. As you create more interference between the two slits, you create more interference by a squared factor, something like that, probabilistically. Okay. So yeah, so the aspect thing has the same smell of it. You know, the same, let's not pay attention to something mechanical as an explanation. Let's, take the extraordinary explanation. Let's find the most extraordinary way to perceive the experiment, the most bizarre way to contextualize it, and then try to explain it that way. So instead of taking something simple and say, we're having a weird result, what mechanically in the process could create that? Instead of doing that, they go to the other extreme and just say, come up with theories like what slit did it go through, when it's sort of irrelevant. What they should be asking is how is the filter changing its polarization? Which clearly is the only thing that can be happening in this experiment. The polarizing filters, they are polarizers, that's what they're called, are changing the polarization. But again, the assumption that polarization can be changed in an individual photon, that the same photon can travel, go through a filter, change its polarization, and be the same photon. Even that assumption is tenuous as a proposition. It's not established fact. There's no evidence or proof anywhere that photons can change their polarization, even mechanically, that you have to exchange the photon. The polarization is what it is. It's like, I'm a white man. You can't make me a black man. But you could have, like, a white man could walk into the drugstore and a black man could walk out. Same thing physically. The store gained 155 pounds and it lost 155 pounds. Same mechanically thing, but it's just not the same thing. And clearly it breaks the idea, if this is true, that the same photon isn't emitted by the polarizer, which I think is a more reasonable truth as a premise. Then your whole spiritually connected photon thing breaks down, because the photon that this other photon is spiritually connected to, that it's doing its, what do they call it? Entanglement. It's doing its entanglement with, it's in an electron in the filter still. This one's going somewhere and doing stuff. This one over here is stuck inside the filter. It didn't go anywhere. It's still in the store. So it kind of breaks the whole idea that the two of them are communicating out here somewhere, because the one you're twins with is still in the store. Anyway, something like that. All right. Yeah, this is, this is work. Yeah. So, what else? No chatty questions. I don't know if the chat even works. I just have no idea. Could type something like V. There, I typed a V. That's enough, right? Choose links. I don't want to do that. I don't want to do a smiley face. Well, they give you really lousy options here. You can do silly stuff or stupid stuff. So, yeah, 47 minutes is pretty good. So yeah, I'll probably just do an hour if nobody else is going to participate. Then that'll be all there will be for this one. I did sort of expect it. Yeah, I just don't, there's no perfect time. So I just figure I should vary it some, so give people some options. I'd like to do them during the day, but there's just too many opportunity for. I have to, I'm sort of on call, and technically, I, do have to go do things sometimes. So it's just not a good idea during the day to try to do something like this. It's my time isn't always my time. Where, low chance of interruption after midnight and before 10 in the morning. I'm usually pretty much free. Pretty much from obligations. So somewhere between those times are usually when I will make a room for, because it's just more practical for me. But I'll do it at other times if there's somebody who's horny for the conversation. All right, so let's see if I can think of a related subject. Kind of want to just take a little break here mentally. But yeah, it's not a subject. I don't know if I want to waste too much time debunking the aspect experiment, but it looks like there's plenty of room for it. Just listening to the rhetoric, and then you hear the context of this whole thing too. This started off as a thought experiment of Einstein's, one that Niels Bohr didn't really have an explanation for, in the sense that Bohr was just kept insisting. I mean, Bohr was clearly religious and clearly had this perception of the universe as some kind of sacred truth, that the mechanics of it were too sacred for us to ever understand or to explore. He really believed the Heisenberg literally thing. I mean, he took that shit seriously, this idea that nothing is in any kind of fixed state. It's not material in any kind of material way until you make it material, until it comes into existence, so to speak. So he didn't really believe the universe exists as something, but until you threw the pancake on the wall, it wasn't a pancake, some kind of crap like that. And that was sort of a sacred truth. I mean, I don't want to call it a dogma, but it's pretty much that's all it was. And Einstein was attempting to come up with these thought experiments to explain how, there's got to be a way we can get to the core of this thing, that we can see what really happens. So the whole point of creating this two-photon scenario, this two-thing scenario, was the idea that you could have two things, and then you could break one over here, and it would be exactly like the one over there. So even though you broke it, you interfered with it, you messed with it, you could learn things that were completely consistent with the other one, because you could tell which things changed anything. And so, you could through that, well, it's not a great way to say it, but the point is that it almost gave you a fake universe to break, and that would give you knowledge of the real universe. So the real circumstance could be exposed by creating a duplicate of it, so to speak, that you could take apart. Something like that. So the point was, Bohr didn't have a real good counter to Einstein's thought experiment until aspects showed up, and then all of a sudden it was this huge victory, because yes, we did this experiment and it comes out to be, photons must be communicating with each other, and then Einstein went, oh, spooky action. That's kind of the story of that spooky action shit. Come on. There's got to be some other explanation. And then photons call each other up, let them know how they're doing, and the other photon starts crying or something. I mean, it's just silly. I mean, it's silly on its face. I'm not saying it's impossible. I'm just saying it deserves a little bit of a funny face you make and say, what? This is going to need some really good evidence. Okay, if you're going to say photons are communicating with each other, you need some really hard evidence. And what they have is really, really just about as soft evidence as you can get, because it's all convoluted and wrapped up in a lot of presumptions, and even the result again is look, there's a 10-degree difference in temperature. It's not like it came out ice and boiling water. No, it's a little 10-degree difference in the probabilistic expectation. And that's hardly enough to draw a conclusion that, oh, it must be. I mean, it's this error rate thing. You just can't, you gotta escape the margin of error. And the margin of error in this experiment is impossible to detect, impossible to write down, but it could be pretty large in terms of your assumptions. If you're not accounting for the photons inappropriately filtered by any polarizing filter. Again, any polarizing filter will kill things that are the right polarization, and it will never let through things that are the wrong polarization. So it makes an error on one side only. So right there, I have a circumstance, like I said, that's probably worth pursuing as an explanation for this result. Because if it wasn't anticipated, it will change your results. So unless they have in somewhere in the math accounted for that difference, that may well be the difference. And that's with, 54 minutes of thought. Now, if I spent 5 days or 5 months picking at this experiment, seems to me probable that I can find other places where we might have a hidden variable that of substance, and a variable not accounted for, an important variable not accounted for. All right, anyway, a relevant variable, a relevant circumstance. It's not even a variable, let's say. Just call it a circumstance. That's what variables end up being, really. It's all circumstances. Everything. That the people and the walls are both circumstances. The walls they bank off of. Anyway, so what else do I want to get to? Don't know if there's any really new innovational stuff I thought of. I do like those kind of documentaries, I guess. I mean, they did have a lot of the historical thing between Bohr and Einstein. And the fact that their relationship did go through a lot of changes. I mean, there were times when they were warmer and colder kind of thing, I guess, depending on how difficult it was to have a conversation, just because, they couldn't agree on a premise. So, you can't really do much conversating about, it's like having a conversation about ethics with a God botherer or something. You're an atheist, they're a God botherer. The conversation is just kind of impossible to have because the dogmatic morality of the religion just doesn't in any way, it's not compatible with somebody who's just concerned with, whether you're hurting somebody, and doesn't really care about whether you praised God or whether somebody anointed you with water, did some other kind of nonsensical ritual, killed a fetus, whatever, offended the creator. I mean, it wouldn't, it's pretty hard to have a rational conversation about ethics in the context where somebody's more worried about offense to the creator than killing somebody or burning them alive or whatever the thing would be. So anyway, I think that's what happened between Bohr and Einstein. As time passed, it got harder and harder for them to have a conversation as Bohr was getting more and more religious and dogmatic, and Einstein was getting, I think, more and more frustrated that physics was just turning into a religion. It was just turning into this wooey, let's find the extraordinary explanation rather than the ordinary explanation. So I do really appreciate Einstein as much as I don't really like. I don't think there's much character or depth to this silly bent space metaphor. It doesn't even work in 3 dimensions. I mean, Einstein should have qualified it as just a metaphor. He should have just said, look, this is just a way of visualizing, another way of visualizing this effect, but it's not a real thing. There's a better explanation for gravity than, you know, empty space bends and then things fall into it and gravity moves them. That isn't an explanation for gravity. I mean, setting up a system, a metaphor, dependent on gravity to work is a really bad explanation of gravity. It's rubber bands all the way down. It's just not a, you know, rubber bands work because there's little rubber bands in the rubber bands. I mean, it's just not something a physicist should feel comfortable with as an explanation. And so I find that kind of, and then even the whole writing on a photon kind of thing that he played with, and the whole creation of the time dilation notion based on this idea that a material thing could ride on a photon. It just led to this notion in people's heads that somehow matter could survive these kinds of speeds. And as soon as you relativize everything and say, we don't know what's really moving, then you really break the idea that there's a real consequence to velocity that has something to do with the matter itself. The matter has the velocity. The velocity isn't an illusion. It isn't something, I didn't know I could unscrew this. It isn't something happening in some, I pour stuff in here. So I do it carefully. Huh. Yeah, whatever. Anyway, sorry. Yeah, I didn't know I could just unscrew that. Anyway, maybe I can put the other heating element inside of this one. That might be a good thing to do. These caps keep breaking. Anyway, sorry. Need my nicotine. Get through the. See, that's, I really, I probably would have figured all this stuff out if I hadn't had to quit smoking a few years ago. Yeah, I'd be way ahead. This nicotine replacement therapy shit sucks by comparison. Really isn't close to the same, but it'll have to do. Anyway, where was I? Oh yeah, Einstein. So yeah, the whole visualization thing. I mean, it's nice to talk in those kind of terms, but it's just such a wrong-headed. It just takes everybody off the subject, which should have been what happens to a material object when it moves. And the whole school of fish analogy, I think, is so, it gets to it so directly. And that's where they should have gone in the first place, was with some analogy that said, look, we have the E equals mc squared thing. We know this energy is still in the matter. And you have to account for its motion inside the matter. The matter already has in it motion, and people kind of knew that. Brownian motion even. You know it already is moving. And you have to know that if you move it very fast, that those motions would add up. The Brownian motion every now and then would be going in the same direction as your velocity, and therefore you'd be going much faster, the little piece inside. So you'd have to go faster than the speed of light if you're going very, very fast. And we know they can't do that, that the little bits aren't allowed to go faster than the speed of light any more than the big bits are. So it just broke the whole perspective on, the whole opportunity to understand velocity as something the thing is doing. The actual thing that has velocity is creating the velocity, the movement, by its material structure has changed. It's not the same thing. Its matter is different when it's not going fast in one direction than when it is. With every mile per hour it moves in a direction, it physically, internally changes in terms of the amount of stuff going one way versus another way, and where the fish are going. The fish change. For the school of fish to move, the fish change their movement. All right, cat needs to come in. Yeah. Pardon me, I can't really stand up for lots of reasons. Yeah. One big reason. Yeah, that's what we'll call it. Sorry, cat wants food. All right, there, I'm back. Unfortunately, yeah, there's no time safe from cat wants. So I did look for him before I opened the room just to see if he would do his thing beforehand, but couldn't find him. Anyway, so past the hour mark, so I think I'll go soon. I think. I mean, I often say things like that. It's funny, I watch some of my videos and I'm basically saying goodbye in the video. It's only it's only halfway through, so obviously I didn't finish. I mean, I went twice as long as the end of the video. So yeah, I mean, I do find ways to keep talking, but I really, I'm not really in the mood, and I guess I'm tired, and so I'd rather just answer questions or be provoked into the conversation in some way to make the work of it more justifiable. Imposing it on myself just doesn't sound quite right for a limited purpose of sloppily dealing with a subject without making a formal video. So, and I really do have to take so much better notes. Yeah, I'm just looking at an image I wrote. I can't really tell what that one was. Interesting, but yeah, I don't know. So I mean, but I'm just saying, I did give it some thought. I was thinking about polarization, and I did recognize this little feature of polarization that I've never heard anybody else talk it. I've never heard anyone else say it overtly. Can't think of any instances where it ever came up. But it is a fact that a polarizing filter will disproportionately cause a null result on something with the right polarization. And it will never create an error allowing something with the wrong polarization to get through. So it only makes that error as a polarizer on the one side. There apparently in magnetism there's a similar slight difference. They say. I mean, I haven't seen the experiments that demonstrate this. No analysis on my part. I'm just going based on what I've heard physics professors say, and I haven't heard talked about much. So it's like only 2 references at the most. But apparently, the negative pole of a magnet is slightly stronger than the positive pole, I think, whatever that means, north, south. Um, the north side is slightly, the repulsive. Well, you can't even say repulsive. That's silly. Well, yeah, apparently it is. It's the repulsive part of magnetism is stronger than the attractive part. Yeah, so it's not a polar thing, north-south. It's in the attraction mode is less strong than the repulsion mode. Yeah, so that's probably worthy of an explanation, because no one's explained that if it exists. I tend to believe it exists just from personal, just when you're playing with magnets. It does seem like that repulsion thing is a little stronger than the attraction thing. It just seems that way. I have no reference for that. But that would be a good thing for me to explore based on my new theory, and maybe come up with an explanation for why there might be a 10% difference, because it might have something to do with this polarizing filters killing one form of polarization. So I can't help but do something that tends to be brilliant almost every day. I mean, it's really, here I'm having this conversation about something completely tangential, so completely perpendicular almost to the subject, right? Aspects experiment with polarizing filters and light. I end up talking about variances, and then I end up to the subject, because of variances, the varying strength of magnetism, and then I'm right back to polarizing filter, because the magnet's a polarizing filter. And it's the very phenomenon I just described that might account for the difference in the repulsive force versus the attractive force, because it's the difference in the amount of kills, the polarization that causes the absence of the gravity being turned into something that goes through the bars is weaker, because some of it's killed by the bars. And the stuff that causes the repulsive magnetism, which is the stuff that gets through and essentially creates double gravity because of the hypersensitivity to the gravity, is the stuff that always gets blocked, always is felt by the filter. The filter always feels frisbees that go this way. And it feels only a tiny percentage that actually hit the bars when it's the right polarization. That's a slight difference. I didn't explain it very well, but you can obviously see how that would account for the difference in the filters. So even though they're, the filters are the same filters, just in different arrangement, and they're filtering the same force, obviously the manifestation of that difference would be realized differently based on what's getting blocked and whether it's being blocked or absorbed. Whether it's not going to matter in the circumstance where it becomes invisible, and it will matter in the circumstance where it's doubled. You're still not going to, there's no way you're going to understand what I just said. Without understanding all the other videos I made, and then understanding the magnetism part and the double thing. But yeah, it's only going to be realized in the thing that's magnifying effect, rather than the one that won't be magnifying the effect. Yeah. So maybe that's a future project. I'll have to do this. I'll circle this good polarization killed thing, because this is really important. Apply to magnetism. So that's a future project. But yeah, the fact that I've never heard that, right? I've never heard anyone talk about the fact that a polarizing filter has an imbalance in its imperfection. It kills more stuff that's right than it permits wrong to get out. So it's like me saying it puts more innocent men in jail than it releases guilty men, or something like that. Yeah. So, good work. But all this stuff, these little bits and pieces that are falling into place, I think they're going to fall into place in a hugely accelerated manner when people who are really smart start playing with this idea, because it just does provide you with a cleaner mechanism. You don't get lost in a bunch of abstractions and trying to imagine waving photons that aren't in any kind of position and aren't doing this and all this bullshit makes it impossible to create models that you can comprehend. It's like Einstein's gravity in 3 dimensions is impossible to comprehend. It's just a big suck. Everything just gets sucked in by the bent space, but it doesn't go anywhere. It just doesn't make any sense. It's a vacuum cleaner with no exhaust. It's non-explanatory, and it creates a foundational concept that you really can't build on. Oh yes, it's like that vacuum cleaner that doesn't have an exhaust. Yes, it just sucks air. It doesn't have to do anything else. Magic, So yeah, that just doesn't provide a mechanism for the shape of the puzzle pieces is so bad. It's like having a bunch of puzzle pieces with a bunch of shapes that just mean like star shapes or little angles, little triangles cut into it, and they all just look like triangles. You can't think of any way to fit them together because they don't have any clean edges. They don't have any conceptual edges that have any coherency, so you can't combine them because they just don't mix. And that's why they couldn't unify physics, is because they created too many mechanisms that were too incoherent to each other. And once you have this clean mechanism, the force carriers are real, and they're carrying the force, but they're real things. They exist. And they balance the field. And it's really the fields are the thing that's really happening, but the fields are created by real things being organized based on polarization. Yeah, but that's the other thing I have alluded to, is that the real complexity of this thing isn't so much recognizing that it's that what's being filtered isn't really mass or the energy itself. It's just the form of the energy. So the interactions are all taking place with a bunch of multicolored little pool balls. And it's not the pool balls themselves that are getting into shapes. It's just the colors are being segregated into filtered mechanisms. But yeah, like I said, that's a level of depth that I don't know if it certainly isn't necessary for this theory to go that far. But that's probably where the real truth lies, is that what we see is what we are experiencing is the filtering of a kind of energy, not energy itself. Not even the right way to say it, but it's not a different kind, it's just a different color. I mean, it is as simple as color. It's an irrelevant circumstantial condition that something's in, but that condition is the universe can recognize it, in the sense the mechanism filters it over time. Yeah, well, I have to get to the key mechanism of that filter, and that's the. I don't know, I'm close to it. It's just that it takes real thought to start thinking about it against a geometry. Thinking in 3 dimensions is really difficult. You can only really do 2 at a time and then try to do a sequence, like build a sentence of those, or a paragraph. It's like a paragraph is a lot harder to write than just a sentence. And a word is a lot easier than a sentence. So it's like, you need to write the whole paragraph to do the 3-dimensional thing. And so in each thought about what's happening in the mechanism, you're always constantly having to try to take a bunch of flashed 2-dimensional images and combine them in your brain into something you can roll 3-dimensionally. And it just happens to be a function that I'm not innately good at it anyway. Maybe somebody else is, but I'm not innately comfortable, because all our images are basically 1-dimensional, and our brain uses tricks to make them 2-dimensional, and then we have to use another trick to make it 3-dimensional. We can't really perceive in 3 dimensions. My eyes are not seeing 3 dimensions. They're seeing a 2-dimensional sheet. You know, I mean, they're seeing up and down, but they're not doing this depth thing in any reality. That's not the image on the back of my retina. Isn't a 3-dimensional image. So it's yeah, it's just hard to do. But that's the trick of it, is that this polarization thing is where this whole thing, that's the key mechanism. And there's a trick in the kinetics that has something to do with when this polarization meets this polarization, something a little different happens. And that's what causes the filtering of the universe into segregated polarization, the creation of orbits. It's the source of the positive and negative electrical field. It's the source of the attractive and repulsive magnetic fields. And the reason why gravity doesn't have that is because gravity isn't polarized. So, yeah. So I think that'll be enough. So, appreciate the people viewing, I suppose. And sorry, no guests arrived. There was a link in the description. At least there should have been. So if there was a problem, let me know. And we'll fix it in the future. But yeah. Yeah. That's it. Now it's an hour and a half video, which is not great, but that's all there was available at this time. So sorry, but that's all we have. It was me. So I guess I could start an hour later and then maybe numbly numb, but I really don't. Yeah, gets a little silly. So we'll just try this again and we'll just see how it works. See if it's possible for it to work. See if it gets more popular, then it won't matter. Then people will show up. Somebody will, worthy of the conversation. Perhaps, maybe, or maybe not. Yeah, you have to endure some failure to get to some success, or whatever the cliche, metaphorical, la, silver lining, blah, blah, blah. But like I say, everything I do is silver lining on this subject. Like I said, this conversation was with myself was useful because I did get to this whole polarization thing and the unevenness in the polarizing filters. And this is, I think, going to be a very useful conceptual notion that has never been, in my opinion, I don't see it explored anywhere, that this is a real phenomenon that takes place in polarizing filters. It's a catch. It's a circumstance that people using filters should be aware of. Yeah, that's the way to put it. So that's certainly makes this hour-and-a-half video worth something, is that it brought to light that circumstance that seems that could be very important. Yeah. So yeah. So even though nobody showed up and it's sort of a failure as a room, it was very useful in terms of its creation of nutrients that will make future conversations richer, more fruitful. Yeah, so it fertilized the future. I mean, that's a phrase you could take a lot of different ways. You know, this bullshit is supposed to do that, right? But we know that bullshit isn't too good a fertilizer. Lots of word games available for use at any moment. So I'll cease to make any words and look at the clock and say, hey, it's ticking. Yeah, I don't really need to look over there to see the time because, you know, it doesn't really matter. And there's no arbitrary rule that I leave at a certain time. Because you see, we always are looking for things to give us an excuse. At least I am. Things to somehow make a decision that doesn't seem to have any, you know, there's nothing really making the decision. And so you're just looking for something to make the decision. So it's not, you know, why is it my job? I mean, I'm just sitting there saying, this ain't my job to make a decision about when I end this room. So you're just kind of looking for something else to make the decision so I don't have to do it. And there's nothing really available. I have a glue stick here. Maybe some way I can make the glue stick make the decision. It's like 70 years old and all dried up, but for certain things, it has a use. Every now and then I had to glue some piece of metal to some other piece of metal, and it's really old glue, so it's you could scrape it off, and so it was useful for that purpose. I mean, you probably can't stick paper to paper, but yeah, washable. It says. I wonder what that means. Washable. See, they put that on stuff, and it's really irritating. Because sometimes they say washable, and know what they mean? It washes out. And sometimes they put the word washable, and it means you can wash it, and it's okay. It'll stay glued. And so you're saying, what does that mean? It's washable. It says washable on there. Oh, you can't really see that. I gotta fix this camera. And it's backwards. Huh. Didn't realize. Yeah, I haven't shown something to the camera in a long time, so I didn't realize it's doing this backward thing. Huh. Anyway, this is the right side over here. That's where it should be. No, okay, so yeah, I know that's a physics optics thing. I'm being fooled. But anyway, it says washable right there, but it doesn't give you any context for that. I mean, maybe the package says, you know, explains what they mean by washable, but it doesn't say anywhere on the glue stick itself. But I assume it means it washes out, which would be a bad thing for me. I don't want things that wash out, frankly. It's like permanent markers used to be permanent, and you know, I don't know what they did to them, but now they suck because it says permanent on them. Like I have these Sharpies and it says permanent on it. I'm sure. Let's see what it says. Permanent marker. Yeah, so it says permanent. It's not permanent. It might be permanent on clothing, so maybe so. I'm wearing a black shirt, so I can't really make it permanent on there, but it doesn't seem to be permanent on anything that really matters. See if it's magnetic. It's not magnetic. It doesn't appear to be. Anyway, there wasn't much chance that it would be. I don't know. Just felt like doing it. Things do surprise you. See, I thought these were made out of like steel, and they're non-magnetic. It's all aluminum. It surprised me. Maybe some nickel or something. I don't know. But yeah, just thought I'd throw that out there. Because it doesn't seem to be plated. I mean, I've never wore off the finish. But yeah, I didn't think you'd get aluminum to stay that shiny. But maybe so. Anyway, what else? Looking at the clock again, see if I can get to 1:30, so then I can say, there's a good decision maker. It decided for me. The clock made the decision. I didn't have to make the decision. So cool. So now that I'm close enough, only 2 minutes to go, I'll let the clock make the decision. So then I'll end the room at 1:30. And that'll be really cool. So I'm sorry, though, that the last couple of minutes of this video weren't very draft sciencey. Well, I mean, there was a little bit of science. Magnetism, is it? Aluminum. That's a scientific kind of word, aluminum. Aluminium. British people. But they really do make some, I got some of these American quarter things that I found. And they're gold plated. I mean, it's really offensive to America that they would allow them to make these commemorative coins that are just such pieces of shit. I mean, it's just it just makes us such a third world country, that we would allow people to put a bad gold plating on a brass coin and, stamp Benjamin Franklin's picture on it or something. That's tacky. I mean, we should have more respect for ourselves than to allow people to make cheesy crap made out of things that are supposed to have integrity, like our Constitution and stuff. It's really bad. Really bad. But America's always been, tacky. It's full of a bunch of crass, tacky Trumpies. So there we go, 1:30. We're done. We're finished and we're completed. So thanks, whatever, to no one for coming. I hope the viewers were satisfied that they got whatever they expected. And if not, really, I could say I'm sorry, but I didn't promise nothing. Did the best I can. I mean, what the fuck? Mostly. I mean, I did mostly as good as I gave it a shot. I'm still talking. Yeah, no, I'm going to leave now. So anyway, thanks. And there's probably a button here I can hit to say goodnight. So good night, Gracie and whatnot.